Alright, so we're going to try to go through a quick lesson here. Something nice and easy for you guys. We're going to be talking about Newton's laws of motions. So I've already talked about motion, we talked about speed, velocity, acceleration, and I've spoken a little bit about force. We talked about net force, and then we talked about balanced and unbalanced forces. Well, now we're going to talk about Newton's laws of motions. So Newton's laws of motion were created by a scientist, Sir Isaac Newton. They're basically, there are three laws that we use to describe the forces and the effect of forces on the motion of objects. Each of these laws are pretty simple to understand, and they're things that we actually see and experience pretty frequently in our real lives. I'm actually going to tilt my camera down just a little bit so you can. Nope, there we go. So let's actually go to the first law of motion. So Newton's first law of motion. It states that an object in motion stays in motion until affected by an outside force. An object at rest will stay at rest until affected by an outside force. Here's what this means. It means that if there's no force acting on an object and it is moving, it will continue to move. And if there's no force acting on an object and it's not moving, it will continue to not move. This is actually known as the law of inertia. The whole idea is, in order for the motion of an object to change, a force needs to be applied. So, one example is if you have like your phone and it's just sitting on, like for me, my phone's just sitting on my desk right here. If I don't touch my phone will not move. If no force is applied to my phone, it will not move. Now, another example, and we're going to use the other part where an object in motion stays in motion. If we roll a ball down a hallway, in theory, it should never stop moving. However, we know that eventually this ball is going to come to a rest. It's going to stop moving at some point. Well, there is a force that is acting on it, and it's a force that acts on us every day, the force of gravity. Because of that force of gravity acting on that ball, eventually it is going to cause that ball to come to a stop at some point. So, this is known as the law of inertia. Inertia is an object's ability to resist changes in its motion. Easy way to think about it is a heavier object will have a greater inertia, meaning it is more difficult to change a heavier object's motion. So another way to think about this is, if you ever driven in a car with a family member and they're kind of driving fast and then they slam on the brakes. If you ever notice, you'll be in the back of the seat, and when they hit the brakes, you'll shoot forward. And the only thing that keeps you from going into the windshield is your seatbelt. Well, the whole reason this happens is because while the car is accelerating and you guys are moving super fast, you're moving fast in the car. The car is moving fast, you're moving fast because you're sitting in it. So what ends up happening is when the car stops, your body is still moving. So your body doesn't immediately just stop with the car. Your body tries to keep going at the speed you were just moving at. That's actually why we wear seatbelts. Seatbelts, the whole purpose is it catches us and stops us from flying into the windshield, because the seatbelt slowing us down causes far less damage and pain than you suddenly stopping by hitting the windshield just going. So that's Newton's first law of motion. To reiterate, an object in motion stays in motion. An object at rest will stay at rest until they are affected by an outside force. Newton's second law. This applies to how strong forces are. Forces depend on two things, only two facts: the mass of an object and the acceleration of an object. You can actually use a mathematical formula to calculate the force of an object. I'm not making you guys calculate anything like that today. Just know that you can do it. That formula is force is equal to the mass times the acceleration. F equals ma is like a shortened version of it, but I didn't write that here. Just know it is the mass of an object times the acceleration of an object that determines the object's force. So think of it like this. If you have a truck and a car and they accelerate at the same rate, which one has more force? Which one needed more force to accelerate? And by truck, I mean like a tractor trailer. It's like one of the big trucks, like the long ones that delivers all the stuff to stores. Obviously, the tractor trailer is going to need more force because it's more mass. It's bigger. The car will need less force. So that's kind of the idea there. More mass means you need more force. But then if you have two things that are the same mass and one is accelerating more quickly, then the one that's accelerating more quickly clearly has the greater force. So Newton's second law, it's force is based on the mass of an object and the object's acceleration. Right here, force equals mass times acceleration. This is our formula to figure that out. Third and final law of motion is Newton's third law of motion, obviously. It's every action has an equal and opposite reaction. So there's actually a lot of really, really good examples of this, but one of the easiest ones is if you ever look at baseball. I'm pretty sure, I don't know how many people here have actually sat and watched baseball, but when the batters swing sometimes and they'll connect the ball, it's actually not uncommon that the more powerful batters will split bats and break bats. Well, why is that happening if they're applying a force to the ball? Well, what happens is when that baseball bat applies that force to that baseball, when they connect, a force is applied to the ball, but an equal and opposite force is applied to the bat itself. This actually is what causes the bat to break. So if you apply more force to that ball and you get like a really good swing out of it, you're going to put damage onto the bat as well. This is actually why, I don't know how many people have done this, but for those of you who have gotten angry and like punched a wall or something, yeah, you'll leave like a huge mark and a dent in the wall, but usually you hurt your hand too. Well, why would you hurt your hand? You're hitting the wall. Well, the force you're applying to the wall is getting applied back onto your hand. That's why your hand is getting damaged when you do that. There are other good examples like that. Like, if you've ever seen, like, when people fire guns, there's kickback to gunfire. That kickback is the equal and opposite force from them firing the gun. That's actually why when people don't know how to... Well, like people in the military, like my older brother, he's an Army veteran. He's told me this. When people try to fire like really powerful guns and they don't know what they're doing, they tend to dislocate their shoulder because of how much kickback they have. That kickback is the equal and opposite force. So every force that applies to something, there's an equal and opposite force being applied the other way. So me hitting something with my hand, that force that I apply to that object is going to get applied back to me. That's the third law of motion. That is it. Those are our three laws. Newton's three laws. Pretty easy stuff. Pretty straightforward. Couple quick questions. I'm actually not going to give you too many. Probably only 4 or 5 for this one. Just take your time, get those done for me, and make sure you hit submit once you're complete. Everyone have a good night. Bye-bye-bye.